Good afternoon, everyone. Today I will be presenting a fundamental concept in database management systems, referential integrity. This principle is crucial for maintaining meaningful relationship between tables in a relational database. We often deal with multiple tables that are interconnected, like customers and their orders, students and their enrollments, etc. Referential integrity means that these links are always valid and consistent. In this session, I will cover what referential integrity is, its key components, real life examples, rules, actions that can be enforced via SQL, and why it is so important. By the end, you will clearly understood how databases stay accurate and how violations can affect data reliability. So, what is referential integrity? Referential, referential integrity is a set of rules that ensures relationship between tables remain valid. Let's say we have two tables, customers and orders. Every order must belong to a valid customer. Referential integrity ensures that if an order claims to be from a customer, that customer actually exists in the database. Does this using something called a foreign key constraint. The foreign key in the orders table must match a primary key in the customers table. Without this enforcement, we could end up with orphan records, orders linked to non existent customers, which would lead to data inconsistency. This concept ensures that data accuracy, reliable joins, and is backbone of relational data integrity. To understand referential integrity, you need to know four key terms. Primary key. This is a unique identifier for each record in a table. No two rows can have the same primary key. Foreign key. A field in one table that links to the primary key in another table. It's how we create relationships. Parent table. This contains the primary key. It is a source of truth. Child table. This holds the foreign key, pointing back to the parent table. Let's use a school database as an example. The student table has student ID as its primary key. This is the parent table. The enrollments table has a student ID foreign key. This is the child table. If you try to insert an enrollment for a student who doesn't exist, that's a violation of referential integrity. Go to the next slide. We can see a real life example here. If in the orders table there is a record with customer ID is equal to 105, but there is no matching entry with the customer ID is equal to 105. In this customers table, that is a violation of referential integrity. This type of error is called an orphan record, a child record that points to a non-existent parent. Such errors can cause serious issues in reports, joins, and logic, especially when we rely on accurate relationships. By applying foreign key constraints, a DBMS will automatically block such invalid entries or deletions, thus preserving the logical correctness of the data. To explain that example further, the orders table should only have a customer ID that exists in the customers table. So if customer ID is equal to 105 doesn't exist in the customer table, it means there is an inconsistency. The child table is referring to a non-existent parent. This is actually what referential integrity prevents. If constraints are set up properly, the DBMS will not allow you to insert or keep such a record. This ensures that the database remains trustworthy, accurate, and doesn't allow broken relationship. That's why foreign key constraints are considered guardians of data integrity in relational systems. Referential integrity is enforced through certain rules that the database must follow. First, the foreign key must either match an existing primary key in the parent table or be null. Second, the DBMS prevents operations that would break this integrity. For example, you can't insert a record in the child table with an invalid foreign key. You can't delete a parent record if there are child records referring to it, unless a rule like cascade or set null is defined. These rules prevent broken references and keep your data model intact and reliable. It also ensures that developers and applications using the database always get accurate and complete data. To handle special cases, SQL allows you to define referential actions on the foreign key. These include on delete cascade. When you delete a parent record, the corresponding child record are also deleted automatically. On delete set null. Instead of deleting the child, it sets the foreign key to null. On delete restrict. DBMS blocks the delete operation if child records exist. On update cascade. If the parent's primary key is updated, the child's foreign key is also updated. These actions let you control how the database responds to changes while still protecting data integrity. You can choose the right action depending on your business needs and how critical the relationships are. Let's look at a basic SQL example to understand how we implement referential integrity. Create table enrollments, enrollment ID int primary key, student ID int. You can see the remaining example. Okay, in this example we are creating an enrollments table. Enrollment ID is the primary key, student ID is the foreign key that references the student ID of the student table. The on delete cascade part means if a student is deleted from the students table, all their enrollments will be automatically removed. This enforces referential integrity and also defines the desired behavior when changes occur in related database. So, why is all this important? Referential integrity helps maintain data accuracy by ensuring every reference is valid, prevent orphan records which cause confusion and errors, ensure correct data retrieval because relationships are reliable, maintain consistency across all tables. Large databases with many users and app access data, it's easy to break links between tables. Referential integrity ensures the structure and logic of data are preserved, making applications more robust and reports more reliable. To conclude, referential integrity is not just a technical concept, it's a critical part of building reliable databases. It is enforced using primary and foreign key relationships, supported by rules and referential actions like cascade or restrict. Without it, data would quickly become inconsistent and unreliable, especially in multi table environments. Understanding and applying referential integrity ensures your data stays connected, meaning, and consistent, which is exactly what every good database should aim for. Thank you for listening. I hope this gave you a clear understanding of how referential integrity plays a key role in database management. Thank you.